Hello guys, very good morning. Welcome back and let's start. In the last session, we discussed about the basics of the Docker. So what is a Docker and why we want to have the containers? What is the necessity of a container? So how the services are looking in the on-premises environment, and then how virtualization has played a crucial role in the entire configuration, and then why we are moving from the virtualization to the containerization. So these are all the things that we have seen in this previous session. Now, what is this containers? What are these containers and how we are going to work with these containers? So before I go into that concept, so for example, you got a promotion in your work. Okay, for example, you got a promotion in your work, and you are about to offer a party to your friends. You are about to offer some delighted party. You invited all your friends to your home. Why again we need to go for some barbecue or else some XYZ restaurants? So come to my home, I will cook some food for you so that we can enjoy in the home. So each and every colleague of you has came to your home. Now you prepared a delicious food. Okay, you have prepared a very delicious food and you offered that food to all your friends. Now when you offer the food to your friends, one of your colleague has said that you made it brilliant. So the taste is very good. Whatever the dish that you have prepared, the taste is brilliant. The taste is excellent. I just want to recook the food in my home. I just want to cook the same food in my home. So can you please give me the recipe? So now what you have done here is you gave the recipe only. So you said how to, what are the ingredients that to be used and how you have to cook that particular food, and you said, and you left the place. Now, when your friend is trying the same food in his home, whenever your friend is trying the same dish in his home, whether he is going to get the same texture, same taste, whatever you have said, is it possible? Do you understand my question here? If you gave the recipe and your friend is trying to do some, he's trying to cook or else prepare some dish, whatever you have prepared, he is trying to recreate that. Is that magic is going to be recreated back in his home? Is it going to happen? Hmm.
This case not 100% sure.
Not 100% should. Why? Because the environment which you have cooked is different, and whatever the ingredients that you have used, he might not be using those ingredients. Why? Because in every home it is not a necessary thing that all the ingredients should be there. In some ingredients may be missing, some ingredients he might use a little bit extra. So that's the reason the same texture and the same food will not be recreated. Now, this is the issue. So when I come back to the technicalities, if I come back to the technicalities, a developer has prepared an application. A developer has prepared an application, and the application is working very good in his computer, in his laptop or else in his computer. This application is running fine. Now, when he gave the same application, when he gave the same application to another developer, okay, now whether the application will be running properly on the another system, is it going to happen, means we cannot say that. There might be a chance, there might not be a chance that the application may not run. Why? Because in his environment, in his computer, the dependencies, whatever the previous, I mean, whatever the developer has used to develop that application, maybe differ from the dependencies what the second developer is using. So there might be a mismatch of dependencies might happen. Because of that, the application will not be properly working in his computer. The application will be working good in your computer, but not in the other computer. So if I move this application to the production grade, if I move this to the production server, then in that server the application might not run. Why? Because already in the production environment there are a few applications running on that server. So this is the reason the whatever the application that you have gave to the production environment, so they might not run properly. So then again you will get back the same response. So the application is working in your computer, not in the server. Please rectify the issues. In our server we are using these kind of dependencies to run the previous applications which are there. So if I try to run this application in my environment, it might not run good. So like that, you are going to get a response from the system administration team or else the production environment, or I will call it as the deployment team. Okay, so now what I have to do? So to overcome this problem, so when we come back to the example, so if whenever your friend said that you when you cook the food, it is very delicious, it is the texture is good and the flavor, it's so flavorful, but why it is not coming the same in my environment? So now what you have done here is you take a container. Okay, container in the sense it's just a box. You take a container. In the container, you have put each and every ingredient as per the quantity. You put each and every ingredient, you prepare, you write a clear cut recipe that this ingredient should be added first, this ingredient should be added next, like that you have given the clear cut ingredients list, and as well as the recipe in a clear cut notes, and you gave the entire container to your friend. So now what you have given? You have given the ingredients, and as well as you have given the complete in detailed recipe to your friend. So in a box, okay, in a box. So the same box is given to your friend. Or else you cook the food. Why you need to strain? Why you need to strain? I will cook the food and I will send the box to you. So you have cooked the food and you send the same box, whatever the food that you have cooked. You put that entire food in a box, in a container, and give it to your friend. So he can enjoy that food. In the same manner, here also the same thing is going to happen. So if there are dependency issues, what we are going to do here is we are going to create a runtime environment, an isolated runtime environment in which we can run the application and its dependencies. So we are going to put the container, we are going to put the ingredients which are helpful for running that application, ingredients in the sense dependencies which are helpful for running that application, and the application source code or build file, everything into a container, into a box, and we will send that container from one environment to the another environment in the form of an image. So this is what going to happen in the containers. So now we have the dependencies, we have the environment. Now we can run that environment in an application called as Docker. Now here comes the main point called as Docker. What is Docker? Docker is an engine. Docker is a containerization engine, container engine, which will be running containers. Okay. Now, what is a container? Container is an isolated runtime environment which will run the applications and its dependencies. So this is what a container is all about. So to run the container, we need to have the Docker, and this Docker is an application where the containers will be running, and inside the containers, you will have the application and its dependency. So you can migrate these containers from one environment to the another environment. We can convert the containers into the images. We can convert the containers into images, which are read-only containers, containers. So images are the read-only containers. So now if you give this image to any another location, so that with the help of that image, we can create the container in the another location in another computer, and inside that we can run the application. So this is called as a container. So to make you understand about this concept, let me do one thing. What I can do here is I have a few images in my Docker Hub. I just want to show you how we can run that particular container. Hmm. Okay, hold on. Hmm. Here we are having AWS CLI, Java. Java is there. Java Slim 11 is there. Hmm. Okay. So in my computer, we are going to install the Docker desktop on your Windows computer. And then what you can do, you can run the application, you can run the container on that particular Docker desktop. So look at here. Hmm. Okay, so now go to the PowerShell. The commands are same either for what I can say, the commands will be the same for Windows or Linux environment. So here you can see docker run hyphen itd hyphen name Java container, or else count app is the name of the container, and hyphen p. I will tell you about all these concepts. Just hold on. 5600. So Chaitanya Manikumar slash Java Slim 11. So this is the image name. So now what is going to happen? A container is going to be created with the name count app, and inside that container we will have a Java application running. So just hold on. Now what I will do here is I will create an Linux environment over here. So let me deploy a server that is called as a Docker server. I am going to create over here, and then I can run the same image in the Linux environment also. So it doesn't matter. Why? Because the containers, the application is running inside the container, which will have the dependencies, runtime environment and a dependency. So this is called as software virtualization, which you are going to experience right now. So launch the instance. It's my docker underscore server. I'll go with Ubuntu. Okay, 2404 is fine. And T2 micro is good. Key pair will be default key pair. Okay, let me do one thing. What about this particular way? Yeah, so the container is ready. So here you can see docker ps, the container is running. So if I try to access the container, localhost 9090, so you are going to get an application. So this is the Spring Boot application where we are going to get this. And so this application is running inside this container. Okay, the application is running inside this container. So how we got the container? Because of the image, whatever the image that we have generated, with the help of that image, we got the container. How these images will be created, you will come to know in the upcoming sessions, not right now. So containers can be created. The point what you need to understand here is how containers can be created. Containers are created with the help of the Docker images. So what will be there inside the Docker image? In a Docker image, you will have the application and its dependencies. So this image is a read-only format of a container. So with the help of this image, you can create a container, and inside the container, whatever the application that is present inside the image will be running in your container. Now let me go back to the server over here. Docker underscore server. I will take the Ubuntu operating system. T2 micro is good. Key pair is the default key pair, and I want to deploy that on-premises VPC. Select an existing security group, default security group, and launch the instance. So the same application I can run in a Linux environment. How we can run this same application on the Linux environment? Why? Because it's a layer. So you need to understand one thing. For example, let me access this server and I will explain you in a clear-cut manner. So this is how the Docker server is available for me. Sudo su hyphen apt update hyphen y and curl hyphen sl https:// get.docker.com on bash. I'm going to install the Docker with the help of this particular command. What is this command? Here we gave a URL. In this URL, you are going to have the Linux shell script. Let me show you that. This is the Docker shell script which you are having. Okay, so with the help of this shell script, we are going to install the Docker on my Ubuntu environment. We will slowly understand. Slowly, we will go into the step-by-step process of how we can install the Docker on your the Docker application on your servers. Okay, so now what I want to tell you here is, now you need to understand one thing. So we have a server. Okay, this is the server hardware. On the top of the hardware, what we are having? We are having an application. we are having an operating system. On the top of the operating system, we are having the Docker application is running. So this is the host operating system, I will say. Host OS. Okay. And then on the top of that, I am going to run the Docker application. This is the Docker application which I am running. So on the Docker application, what I can run? Containers. I am going to run the containers. So containers will not have any operating system. Containers will not have any operating system. They will be using the environment. Try to understand here. I am saying you runtime environment. They won't have any operating system. They will have the operating system libraries and binaries only. So it doesn't have a installed operating system, and it doesn't have any kernel also. So this is the container, and inside the container, what we are going to have? Inside the container, we are going to have the application running. So here inside the container, the application will be running. So now what you need to understand here is containers are not dependent on your operating system. So they will have their own operating system environment. I am not saying that their own operating system will be installed. In VMware, we will be having an own operating system installed. But when you come to the containers, it is going to use the binaries and libraries of that operating system. We are not going to install any sort of operating system. We are not going to install any unwanted dependencies. Only the dependencies which are required to run your application, that dependencies will be there. And this container, now can anybody tell me what is meant by a kernel? What is meant by kernel? Do you have any idea about it?
No.
Anyone? Okay. Do you have an idea about operating system?
Yes.
What is an operating system?
Like an operating system is nothing but the like multiple libraries in files, and it is a combination of uh, like to run the application
Op
smoothly.
Operating system is an interface between the user and the hardware, which will be helpful for running the application,
Yes.
right? So now how operating system will run the application? So who will allocate? For example, I opened Google Chrome, I opened Docker desktop, I opened terminal, I opened Zoom, I opened the paint application. Now how operating system will know that this is the application, this much amount of processor I have to provide, this much amount of RAM I have to provide? Who will decide that factor? So the decision factor will be taken by your kernel. So kernel is a very important component in your operating system, which will be helpful for doing the process management, memory management, disk management, and as well as the network management for your applications. Whatever the applications that are running, how much amount of memory should be allocated to this application, how much amount of processor should be allocated to this application. So without kernel, so that management, the process management, or else kernel is the backbone of your operating system. Without kernel, the operating system will not work. So the application will not run. Why? Because so it is the deciding factor who is going to provide the processor and RAM and storage and network for the applications. So if you don't have the kernel, the application will not run. So in the same manner, so this kernel is an integral part of your operating system. So whenever we are creating an operating system, without the kernel, you cannot create an operating system. To to explain this scenario, we have a very good example. So who is the inventor of Linux operating system? Do you know about that? Who is the inventor of Linux operating system? So it's Linus Torvald. So he is the one who has invented the Linux operating system. But before that, in 1970, there are two persons called as Kem Thompson, Kem Thompson, and Dennis Ritchie. Have you ever heard this word or this name? Hmm. Have you ever heard this name? Dennis Ritchie. Okay. So he is the inventor of C language. Okay. Dennis Ritchie is the person who has invented the C language. They combined, they both collaborated with each other and with a few fellow members in 1970. They introduced a new operating system called as Unix, but it's a premium operating system. So everyone has to pay premium operating system. Everyone has to pay the amount to power, so they have to purchase, every user has to purchase the operating system. There is a person called as Richard Stallman. So he opposed that. Already I am purchasing, already I am purchasing what was that hardware. So I am purchasing the computer hardware. Why again I need to purchase the operating system? I want the operating system with the free of cost. So if you won't provide, I will start preparing my new operating system. He has started his new operating system in 1985, and he named it as GNU. Okay, there is no full form for GNU. Just gave the name as GNU, and he started working with that operating system, but he failed to develop the kernel. Okay, he failed to develop the kernel. He is unable to develop the kernel. In 1991, there is a person called as Linus Torvalds who has invented the Linux kernel, and they attached this Linux kernel to the GNU operating system, and they name it as GNU Linux operating system. So that's how important is kernel. Without kernel, your OS will not be running. So here, Linus Torvalds is the person who has invented that Linux kernel, and and gave it to the GNU operating system. Now everything is fine, and then the Linux has evolved. Okay, the Linux has evolved from Ubuntu, Red Hat, like that. There are so many other names has been evolved, and they made it as an open source and freeware. So this is about the Linux introduction. So now if you see here kernel, so in the same manner here also, what I am saying, inside this container, the application will not be running. So the application is running inside the container, but container will not have an operating system. Then how container will be running? So to run this container, we need to have the hardware support. Without hardware, without processing, without RAM, we cannot run an application. No. So then what is going to happen? The container will say that I want to run an application to the Docker, and Docker will communicate with the host operating system. Host operating system will have its kernel. Host operating system will be having the kernel, and with the help of this kernel, so it will communicate with the hardware so that the application inside the container will be running. If I have to make it very clear, so for example, there is a browser is there, no? So this browser is just like your Docker application. So in this browser I can open multiple web application. Here you can see I have opened the Docker Hub. This is one part of a web application. It might be written in a different language. The front end might be written in a React language, and the back end might be written in some Python language or Golang. When you come to the Amazon Linux. So sorry, Amazon. So here you can see I am having AWS web application. This web application might be written in a different language, but we are browsing it. So like that, here we are having multiple tabs are open. Each tab will have its own process. So now if you can see, the Chrome itself is using how much amount of memory. So if you can see inside the Chrome, we are having so many processes that are running. These are the multiple processes that are running. If I close any tab, a process will be removed. If I close any tab, a process will be removed. So like that, what is going to happen? If you want to run a web application in the backend, some processes will be running. In the backend, some processes will be running. So if those processes are running, you need to have the memory and RAM. So here you can see for this Chrome application, how much amount of CPU we have provided, how much amount of RAM is provided. That will be decided by your kernel. So who is communicating with the kernel? So Google Chrome application will communicate with the operating system requesting for the specified amount of CPU and RAM, and the operating system will communicate with the hardware and provide the specified amount of CPU and RAM. So if I close this tab, automatically what is going to happen? The processors are reduced. So here you can see 17 processors are there, and how much amount of memory is there? It is consuming almost 1 GB. Okay, so now which means that applications are communicating with the hardware to get to run that specified application. In the same manner, if a container has to run, then this container will communicate with the Docker, and Docker will communicate with the host operating system, and the host operating system will allocate the desired number of CPU and RAM. But here I have a question again. So here, whatever the container that you are running is a Linux container. So if you can see, this is an Ubuntu container, especially if I have to say docker execute -it count app and bash. So this is a Linux kernel. So cat/etc OS release. If you can see, it's a Debian operating system. So whatever the container that is running, it's a Debian operating system. But where the container is running on the host operating system. What is the host operating system? Host operating system is a Windows operating system. So here you have an application or container that is related to Linux, and here you are having the Windows operating system and the kernel is related to the Windows. Now, how this container or how this application will communicate with the host operating system? I require this much amount of process and this much amount of memory. So here you are having an option called as WSL. Whenever you are installing the Docker desktop on the Windows environment, definitely you need to install this tool, which is called as WSL. Windows subsystem for Linux. If you don't install that, then the Docker won't be installed on your Windows operating system. What is the meaning of WSL? Windows subsystem for Linux. So that whatever the containers that are having the Linux operating system, these containers can be able to communicate with the Windows kernel, and in Windows kernel will allocate the required number of resources for this application. So this is what going to happen in the backend. Okay, so this is how the containers will be running on the different operating systems, and the containers will be communicating for the process management and memory management with the operating system. So this is about your containers. So what did you understand from the entire topic? From last 30 minutes we are talking, no? So what did you understand from the entire topic?
Here we are trying to
Hmm.
connect from one operating system to another operating system to get the memory or whatever the required info from the particular hardware.
Mhm. That is what you understood. Okay. Any another? Any takeovers from this entire concept, whatever we have discussed from the last 30 minutes? Do you have anything understand? Not about the operating system, not about how they are communicating. What did you understand from the beginning? From last 30 minutes, we discussed so much things, right? So what did you understand from that?
Like every operating system have the kernel, it will have the specific rules to specific roles to give the like process or memory or device managements in the kernels
Mm-hmm. Mm-hmm.
and the
I'm talking about the containers. You are talking about the last 5 minutes part. I'm not talking about that. What did you understand from the container? What is a container? If anybody asks you in an interview, what you are going to say?
like a container. Oh, okay. Like a container means without having the entire operating system, with only binary
Mm-hmm.
files and library files, we will have without all
No,
those
that is not.
information.
No,
So,
that is not the
con
definition which I have given for the container.
so container is basically a
Mm,
independently running application
mm,
or a running
mm,
basically a running state of an image, not just the read-only state, it is a container. So
mm, mm,
when an image is run, it's in running state, they are called containers, and containers are basically a runtime which carry in the Docker engine runtime which can have applications, libraries, or any other softwares that can be used in that running containers.
mm. No, I'm confused about that. A container is an isolated runtime environment in which you can run the application and its dependency. You did not say application and its dependency. If you
They
don't
said
say that word,
application libraries.
then there
I mean,
is no. That's a different one. You said about the operating system. We don't have the operating system, so we will use the libraries and binaries of the operating system. You did not
no,
say
no,
about
no.
the application and its dependency.
I meant to say, so containers are basically when we execute whatever we have in the in an image, a running when the applications or dependencies or a
Here, there
library.
is no necessity of images. Okay, so when you have to define about a container, you don't need to define about the images. Yes, of course, I understand images are very important to run the containers. But if anybody asks you what is a container, define a container, then it's a very simple, straightforward, one-line answer. A container is a runtime environment where we can run the application and its dependency. How applications and dependencies are came, that we can say with the help of the images. But the point is, you are connecting multiple things into a single definition. So then when you are attending to an interview, in interview, if somebody asks about what is meant by a container, you are going to bring the Docker images. You are going to bring the kernel into the picture. So when you bring all these into a picture, then you are giving a large scope, huge scope to the interviewer to ask the multiple questions related to those things. That is not necessary, no. So whenever you are attending to an interview, so you must be very crisp and you should be in a very shorter format. You need to make it clear for the interviewer. Otherwise, if you say all these things, no, then you are giving a chance to the interviewer to ask you multiple things. So if you say the Docker image container is created with the help of an image where we will have the application and libraries and binaries, then he will ask you what is meant by a Docker image. You have to tell about that. And when he asks you about the Docker images, what are the instructions that will be there inside the Docker image, how you can write the Docker image, create a Docker file and generate a Docker image. So you gave the chance to him. Why we need to give the chance to the interviewer? So you need to be making it very crisp and it should be a single line answer, so that he will be going to the next question. He should not ask you when you are saying an answer in the interview. So the interviewer should not pull out a question from your answer. He has to find out another question. That is how you should say. So if I say that a container is a runtime environment, isolated runtime environment in which I can run the application and its dependencies, it's a very simple one, no? So inside the container, we are going to run the application. It is true. So how applications will be running up? If I have to run an application, definitely I need to have the dependencies. So these dependencies are also incorporated inside the container. And one container will not have any connection with the another container. So it is an isolated environment. So simple answer. Okay, so you should not say that Docker images and everything. Later we will discuss. Later, if he goes to another question, say the answer relevant to that question. Don't say the answers with all the things whatever I have said you. I said you all the things to make you understand what is a container. But that doesn't mean that you have to say the same answer in the interview. Okay. Am I clear here?
Yes.
Hmm. So that is what a container is all about. A container is an isolated environment in which you can run the application and its dependencies. Now, how a container got introduced. So when the Docker was introduced in 2016, or how who has introduced this container, how this container got implemented into the IT world. So now, before I go into that, so in Linux, there are two features are available. What are those? One is the namespace, and the other one is the C groups. Okay, what is this namespace and C groups? Let me explain you in a clear-cut, detailed manner. For example, you are studying in a session. Okay, you are studying in, for example, you are studying in a class. Inside that class, you will be allocated with the roll numbers. Each and every student will be allocated with a roll number. So this why each and every student has to be allocated with a roll number? Why can't they read with their own names? Why I need to provide your roll number one, your roll number two? Why we need to do that?
Duplications.
Hmm. To avoid the duplications. Very good. So now in the same manner, in our computer also, we have the applications running, no? So whenever the applications are running, so each and every application is going to be isolated with the help of process ID. So process ID is a type of namespace. So now what is this namespace actually will do? Namespaces are helpful for you to segregate the processes which are running in your operating system. In the same manner, how roll numbers are going to be segregating the student. So your roll number is 10. So if anybody comes to your class and says that I want the roll number 10, so you will be standing out and you will be going with the person whoever has called. So if somebody will come and says that I want roll number 20, so roll number 30, like that, what we are going to do, we are going to segregate each and every person depending on the roll number, so that the duplications will not be there and the interconnections will not be there. I cannot provide the same roll number for the same two persons. Each and every person will have their own unique roll number, so which is going to isolate that person with the another person. If I allocate the same roll number to the two persons, then what is going to happen? Then conflict will occur. So that's why here also, whenever the application is created, each and every application will have its own process ID. So process ID is a type of namespace. And not only that, for example, if I want to run an application, so in a computer, I am running an application on port number 80. Can I run another application on the same port number in the computer?
No,
What is the answer here?
no,
So I have a computer. Yeah, it's no. I have a computer and I am running an application on port number 80 on this computer. I try to create one more application on the same port number, then it will not allow that application to run on the same port number. So here it is also, the networking is also isolating. The applications should be running on a particular port number. They should not be running on a same port number. So this port number is also helpful for segregating the applications. So the process ID, application, I mean the networking concepts, everything is interlinked with the namespaces. So whatever the process ID that you have seen, that is a process ID namespace. Whatever the networking namespace that you have seen for segregating with the help of ports, that's a networking namespace. These are helpful for the developers to create the containers. So that's how the containers has came into the picture. So for example, when I try to create a container, let me create a container. How I can create Docker PS? Here already I have a container running on the port number 9090. If I try to create another container, Docker run -itd -name, new container, okay, -p 9090:80, and with the help of nginx image. So I'm going to get an error. What is the error? Already on port 9090 there is an application running, so I cannot create the container on port number 9090. You are going to get an error. See there. There you go. Error response from the daemon. Driver failed. Programming external connectivity on the endpoint new container. Bind 009090 failed. Port is already allocated. So you cannot run two containers on the same port number of see what I am doing here is, this is the server side port number and this is the application port number. I did not understand. Okay, let me make you understand about this concept. So we have a computer or else we have a server. This is the server. Inside the server, what we are doing, we are installing the Docker application. So this is the Docker application which we have installed inside the server. So now inside that Docker application, we need to run the containers. Inside this Docker application, we need to run the containers. So now if I create a container, and inside the container, if I am running an application, why we want to run this application? To provide the access for the external customers or else external users. So this is the application which I am running right now inside the container. Now application will be running on a different port number. For example, this application might be running on 5600 port number. So if I want to access this application, I need to enter into the container on port number 5600. This is clear. But first of all, if I want to enter into the container, the request must enter into which device? If I am on the internet, from my computer, if I am trying to access the application from my computer, if I am trying to access the application over the internet, so what I will do, first of all, I need to connect to the server, right? From the server only, the request will go inside the container. Without entering into the server, is it possible for us to enter into the container? Tell me.
No.
No. So without entering into the server, we cannot enter into the container. Okay. So now here to enter into the server, there should be opening, no? So for that, we need to provide a port number. So here I am providing the port number 9090. So whenever the user is hitting on the server on port number 9090, that request. So that is what here you can see clearly. So look at there, anything from the internet, 0.0.0 means from the internet. If anything is coming on to the port number 9090 of your server, that will be forwarded towards your application port number. So here, whenever I am hitting on the server on port number 9090, so then what server is going to do? Server will forward that request to the container application, which is running on the port number 5600. Okay, like this. If I create another container, inside this, I can run an application. Inside this, I can run another application. So now what should happen here? This application will be running on the port number 80. So when it is running on the port number 80, so if I open the same port number 9090 on the server, can I open the same port number? What is going to happen? If I connect this application to the same port number, then what is going to happen?
Ambiguity.
If any, yeah, so there will be ambiguity, and as well as there will be duplication and confusion will be there. So the server will not understand. So the user is requesting on the port number 9090. So to which application I have to forward the request, whether I have to forward the request to this container or else this container. So there will be a confusion. So to overcome that, what we are going to do, we are going to isolate this port number. Already once the port number is given to an application, we have to provide another port number. So this is what the networking namespace. We are going to have the isolated environment for each and every container to run an application on a different port number. So this is called as a namespace, networking namespace. Not only that, when we create a container, let me show you on the Linux environment over here. What is the command that we are going to use to check the processes in a Linux environment? What is the command that we will be using to check the processes running in a Linux environment? ps-ef. So if I go with ps-ef grep containers, okay, grep container, sorry, not container, containers. Here you can see we have a Docker application running. So this process ID belongs to my Docker application. So now what I will do here is, let me go with tmux. Tmux means terminal multiplexer. Here I am having only a single terminal. I want to divide this terminal into two terminals. Tmux, control B, shift double quotes, control B up arrow, watch -n1. I'm going to give like this, ps-ef grep containers. Grep containers. Here you can see, not the containers, container. Okay, here you can see we have a process ID related to my Docker application. Now I am going to create a container over here. Docker run -itd -name test container one with nginx image. So when I create this container, automatically what is going to happen here means it is going to create a container with a process ID. Look at here, a new process will be created. Look at there, 2947. This is the container process. So what is the container ID? D36A EC. So here you can see Docker PS. What is the container ID? D36A EC. So here you can see that. So which means that a container is created. Whenever a container is created, a new process will be generated in your operating system. And as well as if I try to create another container 2, okay, a new process ID will be generated. Here you can see this is the another container. So this container 1 doesn't have any connection with the container 2. See, what is the meaning of connection here? Let me explain you. For example, you are in an office. You are in an office and you have your colleague besides you. You are sitting on a desk. Besides you, you have multiple colleagues are there. Now you will be allocated with a computer. Your colleague is also allocated with a computer. Now, whether both the computers will have a connection, yes, you have a connection through the networking. But what is my question here? If you run an application in your computer, the same application will be running on the another computer. Is that going to happen? For example, if you open the Google Chrome, is Google Chrome is going to be opened in the second computer or else in your another employee computer? Is it going to happen?
No.
Which means they are in the isolated environment only, no? So which means that whatever the work that you are doing on your computer, the same work will not be done on a secondary computer. So they will do their own work. But if you see externally, through network, they are connected. If you want to transfer the data, you can transfer the data or else you can collect the data. But if you think logically, one computer, your computer will be in an isolated environment with the another colleague's computer. Whatever the work that you are doing, you will be doing in your computer only. Whatever the work that is done by your colleague, he will be doing his own work. So which means these two computers are in isolated environment. But externally, they are connected through the network to transfer the data. In the same manner, whatever the containers that are created in our Docker environment, each and every container will be isolated with each other. They will not have any connection, or else whatever the application that you are running on this container, the same application will not be running on the secondary container, the second container. So these are isolated with the process IDs. So that is what another namespace, process namespace or else process ID namespace. So with the help of these namespaces, the inventor of Docker or else the inventor of the containers has described that, okay, so in Linux, we can use these two features. One is the namespace. Just now we have said, we discussed about that process ID namespace and networking namespace. With the help of these namespaces, we are going to create an isolated environment to run the application. And that isolated environment to run the application is called as a container. And there is one more feature that is available that is called as C groups. So what is meant by C group? If I create a container, for example, I created this test container 1. Okay, this test container 1 is running on this process ID. Now, if I don't specify the resources, so this container has to use only one CPU, 4 GB of RAM. If I don't specify that, what is going to happen? Let us take an example of your Java. So you have your Java application running, no? So when the Java application is running, in the beginning, it is going to consume lot of memory. So at that
Sorry
time,
to cut
if
off
I,
you, Chaitanya. I have a small question.
Mhm.
I'm a little bit confused here. Sometimes we are discussing about the Docker and sometimes we are talking about the container. Can you just give me the what exactly difference between the Docker and container?
I'm not talking about Docker anywhere here. I'm talking about the containers only.
No, sometimes we are using
Where I
this
Docker
Docker, right?
containers. See, Docker and containers both are the same. If I have to tell you, have you ever visited any port,
Yes,
ship port?
yes.
What will be there inside the port?
You are asking the.
So
Go ahead, go
to
ahead.
export and import the goods, what you will have?
Yeah,
You will
some.
have the containers, no?
Yes,
Who will take that containers to
ships,
one country to the another country?
ships.
Without ship, is it possible to take the containers?
No.
With no, right? So here Docker is like a ship and containers are like the environment where you can run the application, where you are going to store the goods. So without Docker application, is it possible to run the containers? Are you able to understand? Docker is an application where you will have the containers. So I did not use any word precisely like in Docker or in containers. Try to understand a Docker is an application where we can run the containers. From the beginning onwards, I am saying it the same, no? If you see this diagram, what did you understand from this diagram?
Yeah. Oh, the container is on top of the Docker.
On top of the Docker, it is running on the containers are running on the Docker. Docker is, if Google Chrome is not there, are you able to open the tabs? Just assume that Google Chrome is like Docker and these tabs are like containers. So each tab will have its own application, no?
Okay.
Without Google Chrome, is it possible to run the containers? I mean,
No.
run this tabs or also open the tabs. Without the Docker, is it possible for us to run the containers?
But okay, maybe I have a question, but not the relevant one. Actually, I had one more point is a container can exist without Docker. Is it possible?
Again,
Yes.
if I want to, one second. If I want to open the AWS application, I can open the AWS application in the Google Chrome, in the Firefox, in the Safari browser, in the Edge browser. Did I say anywhere that I cannot open the AWS tab or else AWS application? I have to open only in the Google Chrome. Did I say anywhere? Docker is just like an application. So not only Docker, you are having so many another containerization platforms. One is Containerd is there, Podman is there, Raw RKT is there. Like that, there are so many different applications. So that's why in the beginning only I said you, here we are not going to discuss about the Docker. Docker is just an application to run the containers. In the first class itself, I said you that containers are can be running on any containerization platform. Either you can run that on the Containerd or else you can run on an RKT, you can run on Podman. These are all the applications, just like your browsers. How many browsers that you are having, just like those browsers, you are having so many containerized platforms. On the top of that, you are going to run the containers. So Docker is just an application to run the container. Is it clear?
Yeah, got it.
So from 2 days, you don't understand the entire concept. Whatever we have discussed now, it is almost 1 hour. You are at the end of the session, you are asking this. I said you in the beginning only. So we are not going to discuss about the Docker. We are going to discuss everything about the containers. Docker is an engine which will be helpful for you to run the containers. What will be there inside the container? Inside a container, you will have an application running. So these applications will be, and the containers will be isolated with the help of the features called as namespaces and C groups. So all collaboratively, we are discussing from the beginning. Okay. So that's about your containers. Any questions rather than other than this?
No, no, no. Continue.
That's it for today. So any questions related to the containers? Any questions related to the Docker? Mm-hmm. Yeah, Kishore.
No, no, no.
Kishore or who is about to say? Okay. Right, guys. So let me go with the. Actually, I have to give the syllabus, but any which ways, you can check out the DURGASOFT website from where you can get the syllabus. The course duration will be 25 days. Most probably it will be 20 to 25 days. And then we are going to discuss the class timings will be 8:30 a.m. to most probably 9:30 or 10 a.m. And what else? What else? Here we are going to have a clear cut understanding about Docker and Kubernetes. And you are going to get everyday videos and documents. Okay, related to your subject, whatever we are going to discuss. Okay, so this is the second demo. Tomorrow you will have the last and final demo, and from day after tomorrow, whoever has enrolled for the session, they will be getting a premium link. Okay, so those who are interested can join the session. So that's it from my end. If you have anything else to ask me, you can ask me.
Uh, yeah, I do.
Hmm,
I know there is a, I don't know if there is any Docker certification for Kubernetes. I
hmm,
know you mentioned Kubernetes
hmm,
administrator, developer, something like that.
hmm,
So after
hmm,
25 days, if
hmm,
a candidate puts in effort from his or her side,
hmm.
is it fair to say that one can appear
You
for the
can crack the
certification?
certification. You can,
Yes.
with the help of this course, you can clear out the CKA certification. Okay, Certified Kubernetes Administrator certification. If you put
So
your efforts.
just for my knowledge, if a person is from a
Hmm.
developer background, will a CKA or CKD will be, I don't know what's the difference, but
CKA, both are the same, but most probably both will be equivalent certification. But I recommend you to complete the CKA certification. Okay.
okay, and CKD is the next level or something?
It's pretty next level we will discuss when we go into the Kubernetes. I will give you the clear cut certifications what you have to do. But
Okay,
the level of certifications which you can do over here is CKA certification, and then you can go with CKAD also. That's not a very big problem. And later you are having the professional level certifications are there. We will discuss that when we go into the Kubernetes. Okay.
this course will help for that.
Yeah, this course will be helpful for that.
Okay, thank you.
Right then. Have a nice day, and we'll meet in the next session, guys. Bye.
Thank you.
Thank you.